Let's talk about operations on functions, and it's as complicated as it looks when we start using all the function notation. It's really boils down to just doing the same kind of operations you already know, only we're going to, instead of simple terms, we're going to do it with whole expressions. This chart up at the top is just a little bit of a reminder, because if you look over at your instructions on your assignment, it's not ever going to say find these sums specifically. We're just going to give you the notation where it says add f and g together, right? But that way you have this reference chart right here so that you remember how these all translate, what this really means. This right here is just a reminder. If I'm going to divide things, I can't divide by 0, so that can't be 0. That's all that is saying. Okay, this is our little kind of translation guide to what's going on. We'll work a couple of examples. Right here, if we're adding functions together, so this shows we're going to add f plus g, and so it's expanded to f of x plus g of x. So I'm going to go back up to what we were given, where it says f of x is x squared plus 3x minus 4, and we're going to add that to our g of x, which is 3x minus 2. Okay. Now, addition doesn't change any of the signs, so I don't really have to worry about parentheses or anything. We're going to in a minute. But once I write these down, it's just a matter of combining like terms. There are no other x squared terms, so we're just going to write this one down. Done. 3x plus positive 3x is positive 6x. And then negative 4 plus negative 2 is negative 6. That's it. F plus g of x equals x squared plus 6x minus 6. No big deal, right? It's just combining like terms. Easy enough to deal with. When we're subtracting, now we are going to have to worry about parentheses, because if I think about distributing this negative, it's going to change every sign that's in that g of x. So when I substitute in f of x, x squared plus 3x minus 4, minus, I'm going to go ahead and set up parentheses so that I can write that down in there, my g of x, 3x minus 2. And then we're going to rewrite and take care of this distribution first. So x squared plus 3x minus 4, negative times positive is negative 3x, negative negative makes that positive 2, and then we can combine like terms. So again, there's only one x squared. Now we're looking at positive 3x and a negative 3x. Those cancel out. I'm going to write down 0x here just so you remember where it comes from, but we're not going to write that down at the end. And then negative 4 plus 2 is negative 2. When I simplify even further, I'm not even going to write this one down. F minus g of x equals x squared minus 2. Okay. Order is important. If this had said g minus f, then we'd have written the g of x first and then subtracted and put this in parentheses to distribute that negative through. That's really the most difficult thing, is making sure you're paying attention to what you put where. Okay. Multiplication of functions. It's really just a lot of distribution. Okay, so we're still going to plug in, but this time we're going to put these in parentheses so that it just looks a little more familiar. So the first thing we're going to write down, x squared plus 3x minus 4. And then in parentheses with that, 3x minus 2, because that's my g of x. And then we're going to distribute. Now, I can distribute 3 times, right? Once for every time in this original parenthesis, or I can rearrange, because order doesn't matter with multiplication. So because this one is smaller, it has fewer terms, I'm going to distribute these two so that I don't have to do everything 3 times. Okay? So we're going to distribute, and I'm going to rearrange. 3x minus 2 times x squared plus 3x minus 4. And then we're going to do just what you're used to doing anytime you've ever seen this before. 3x times x squared is 3x cubed. 3x times 3x, positive 9x squared. 3x times negative 4 is negative 12x. Negative 2 times x squared is negative 2x squared, and I'm going to write it under this other x squared so that it's easier to combine terms later on. Negative 2 times positive 3x is negative 6x. Again, I'm lining up my like terms to make things easier when I'm ready to simplify. Negative 2 times negative 4 is positive 8. And then they're already lined up, so it's easy to simplify and write everything down. There's only this one, 3x cubed. Positive 9 and negative 2 is positive 7x squared. Negative 12, negative 6 is negative 18x. Bring down the positive 8. And that is f times g of x. Nothing new, we're just using old skills in a new way. Organization is what's really most important. All right, division of functions. Again, order is important. Addition and multiplication, I can do in whatever order I want. It doesn't matter. We don't have to worry about signs changing. We don't have to worry about forwards and backwards because everything just combines the like terms as we move through. Division and subtraction, though, make a difference, right? If I had done this backwards, then all of these terms would have changed signs. Same thing with division. I have to be careful and make sure that I'm putting f of x, which is this one, over g of x, which is the second one. So when we write this down, x squared plus 3x minus 4 divided by 3x minus 2. Now, when we look at this, I know that this can be factored, right? If I think back to that rule, I can rewrite this as x plus 4 times x minus 1. And then divided by 3x minus 2. I'm going to go ahead and put that in parentheses. This can't simplify anymore. There's no common denominator that I can pull out. There's no common factor. And when I look at my numerator, these don't have anything in common with that either. If this had matched one of these factors exactly, we'd be able to cancel it out and simplify. But because we can't, we're just going to leave it as is. And that setup is f over g of x. We're just going to leave it alone. We'll look at some together where maybe we can factor some stuff out, but the important thing right now is just making sure that you've carefully set it up.